the previous class we have discussed the axiomatic theory of probability. Let's see some results of probability. And the first result is if A intersection B is equal to 5. That means there is no relation between A and B. And since it is 5, 5 is an impossible event and probability of 5 will be 0. Therefore, by the axiomatic definition of probability, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. And since probability of A intersection B is equal to 5 and it is 0, the final result will be probability of A union B is equal to probability of A plus probability of B. And this is the first result of this theorem of probability. Now let's discuss the second result. That is probability of A union B is equal to 1 minus probability of A union B complement. And we know that complement is something that is included in the sample space but not in A union B. That is, A union B will be an event of sample space, and A union B complement will be other events than A union B. And therefore, by the algebra of sets, A union B complement is equal to A complement intersection B complement. So we are applying it here, and that is 1 minus probability of A complement intersection B complement. And it means that probability of occurrence of at least one event, that is probability of A union B is equal to 1 minus probability of none of this is occurring, that is probability of A complement intersection B complement. This is the second result. Now let's see the third result, that is probability of A union B union C. And here we have one more additional event, that is C. So we have here three events A, B and C. And A union B union C, the probability of A union B union C is equal to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of A intersection B intersection C. And these three events are not mutually exclusive events. And we have the result 4. Here there is a slight difference, that is, and these three events are mutually exclusive events. That means probability of A union B union C will be probability of A plus probability of B plus probability of C. And you just recall the probability of A union B and probability of A union B in both sets, mutually exclusive events and not mutually exclusive events that we have discussed in the previous classes. And the result 5 is probability of A union B union C, that is 1 minus probability of A union B union C complement, that is 1 minus probability of A complement intersection B complement intersection C complement. You just recall the result 2 that we have discussed just before. And these are the 5 results of the theorems of probability. Now let's discuss an example problem. And here the question is probability of A is equal to 1 by 3. Find probability of A complement. And from the axiomatic theorem of probability, by the theorem 2, we have probability of A complement is equal to 1 minus probability of A. Now let's just apply what we have. 1 minus probability of A is equal to 1 by 3, that is 1 minus 1 by 3. And the final answer will be 1 minus 1 by 3 will be 2 by 3. And therefore the probability of A complement here will be 2 by 3. Now let's solve another question. Here we have a question, probability of A is equal to 1 by 2, probability of B is equal to 3 by 4, and probability of A intersection B is equal to 1 by 4. Find probability of A union B. We know that by the axiomatic theorem of probability, we have theorem 3, that is probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. And this is the third theorem of probability that we have discussed earlier. And we have the values here. Probability of A is equal to 1 by 2 plus probability of B is equal to 3 by 4 minus probability of A intersection B is equal to 1 by 4. For simplicity, let's see the denominators, the similar denominators, that is 1 by 2 plus here 3 by 4 and 1 by 4 have the same denominator, so it can be written as 3 minus 1 by 4, and that is 1 by 2 plus 2 by 4. By simplifying it will be 1 by 2 plus is 1 by 2 again, that is 2 by 2 is equal to 1. And the final answer is probability of A union B is equal to 1. And this is the result, and you just work it out. Let's work out another question. That is, if probability of A is equal to 1 by 8, probability of B is equal to 1 by 6, and probability of A union B is equal to 1 by 4, find probability of A intersection B. From the addition theorem of probability, we know that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So, we have to find out probability of A intersection B. It's this one. And so I am writing it as probability of A intersection B. Taking it one side, probability of A plus probability of B minus, that is probability of A union will be coming to this side, probability of A union B. So we have the when the values are probability of A is equal to 1 by 8 plus probability of B is equal to 1 by 6 and probability of A union B is equal to 1 by 4. By simplifying, we will be getting 1 by 8 plus 1 by 6 and multiplying both sides with 2, and it will be 2 by 8. That is 2 by 8. And so the denominators are the same. So here it will be 1 by 6 minus 1 by 8. Final result will be 8 minus 6 by 48. That is 2 by 48 is equal to 1 by 24. And you use your own method to solve this problem, and the final result will be probability of A intersection B is equal to 1 by